Hello, my name is Elena and I am part of the Programming Homework Help team. Today I'm gonna make a demonstration on how to make a linked list in C++. I'm gonna start giving a brief introduction of what a linked list is. A linked list is a form of ordered linear data collection that stores elements of the same type of data. Each element is connected to the next one using links. This concept can sound similar to an array, so let's see some of the main differences between an array and a linked list. It's not possible to access the elements in a random way. The elements will have to be accessed sequentially. The new elements can be added anywhere, and we create a new reference for that element using pointers, so it doesn't need to be continuous. The size of the linked list changes as elements are added or deleted, so we don't need to specify a size like in arrays. Here we can see an example of the structure, where the linked list is a collection of this data and links. The letters represent the data stored on each element, and this arrow represents the link to the next element. Each node consists of two parts, the data and the link. Also, we will refer to the head and the tail as the first and the last elements on the linked list. This last element is not linked to any other, so the link will be null. Now we will demonstrate how to do a linked list. I'm gonna start showing a scheme of the program. This will be composed of three principal elements. One of them is a node, which will contain the data and the pointer to the next element. The second one is a structure for the linked list, which describes the relation between the nodes and what will happen if we add or remove elements or any additional features like the use of operators. And finally we have our main program, in which we will call these two functions depending on what we want to do. For this part, we start like in any other program, calling the necessary libraries. In this case, we only need iostream, and we set a standard namespace. We start making a class for the node section. It will be public, which allows us to access these elements from any function. Then our data type, in this case, will be an integer type of data. And then we make a variable next that will be linked to this node. Now we will have two different types of variables linked to our node, which will be the data and the variable next that will take us to the next element. There is also two interesting commands that we will use along the code. These are null ptr, that in comparison with the typical null value will help us to avoid ambiguities, and also the variable this that will allow us to identify specific objects when we call a function. Now we will continue to the second element, which is the linked list, and this will contain all of the functions for the data. We start allocating the nodes for the head and the tail, and we keep on track especially on the head node, because this will give us access to the whole list. We link the values for the head and the tail. In this case, we don't have any data yet, so we only specify head with its own value and a null value for the tail. For adding a new element, we can either add it at the start or at the end of our dataset. We can do it with these two parts of the if function, so we can make a new node depending on the value of the head. The new element will take the place of the head or the tail. Now I'm gonna show how to add an element at a position. For this section, the program will ask the user to give two integer values, which will be the data and the position for this new element. When the user inserts a value for the position 1, we will need to move the position of the current head variable by using a temporary node variable. then create a node for the new data. When this is not the case, the program proceeds to use a cycle to find the position for the new value, and moves the current value to the next position using a temporary variable. If the position is not found, the program will tell the user that the position given is greater than the length of the given list. Then we'll add the element at the end of the list. To remove an element, the user will provide the position of the element to remove. If the position to remove is the first element, we will assign the head position to the next element on the list. If this is not the case, a cycle will read each position of the list until find the given position. Then this element will be removed. If the given position is bigger than the length of the list, the program will warn the user and no element will be removed. Now, the function for returning an element value in a position is pretty simple. The user will provide the position of the element of interest, then the cycle will read the elements until it finds the position given. Then it will return the value of that element. If the given position is not found on the list, the program will warn the user. This simple command line will allow the operator to access private class members. This function will be important for being able to use operators in lists. Other of the things we want to be able to do is to be able to use the sum operator in two lists. So in this case, we will create a copy of the list so we don't have to build another additional list structure. In the next part, we see that we are using this copy to be able to sum these lists by giving a specific function to the plus operator. This function would return the sum of two lists. In C++, it's possible to make operators to work for user-defined classes. To overload an operator means to provide special operators for a determined data type. So we proceed to use this command in which we will have our operator of interest that will read the linked lists. Then, on the structure, we can see that the program recognizes an empty list by just reading the head, giving a warning to the user. If this is not the case, the program will add an arrow between each element to symbolize the link between them. Now that we have enough functions to test our program, we can make a main section and add different commands. As final conclusion, we can see that the linked list created here is able to add and remove elements, return values for given positions, show the values of the linked lists, and use special operators. We hope the video was useful for you. For any help with programming homework, you can visit our webpage programminghomeworkhelp.com or send an email to info@programminghomeworkhelp.com. Thanks for watching.